Okay, so as a continuation of our lesson solving systems of linear equations by elimination this time. So the first one was by graphing, the second one was substitution, and this time by elimination. An important information about this is you must decide which variable to remove or eliminate. So let us look at the first example. I'm looking at the 3x and the 5x. That's kind of difficult for me to remove. But I'm looking at the positive 4y and the negative 4y. And that is very easy for me to remove if I add. So I'm now adding. So we are going to go ahead and add this up. So 3 plus 5 is 8x. Adding the same number with different signs makes this a 0. And now this becomes equal 16. So now let me just add plus 0 here just for you to see that. And this now becomes 8x equals 16. Divide by 8. Divide by 8. X is 2. Now you have the x coordinate. What you want to get is the y coordinate of your intersection point of these two lines. So you can choose any of the two. I'm just going to go ahead and substitute here. So again, we have 3x plus 4y equals 12. And since I have the x here, I'm going to put this inside the parentheses. Copy everything and then plug. So that's a 2. This becomes a 6 plus 4y equals 12. This is 4y equals 12 minus 6. This is 4y equals 6. Divide by 4. Divide by 4. Your y is 6 out of 4 or 3 out of 2. Your solution or your intersection point is 2, 3 out of 2. Okay, so example number 2, 2x plus 5y equals 20, 2x minus y equals 8. Okay, so again, our method is by elimination. So, looking at the x and the y, I am thinking that this is easier to eliminate, but this time, since the signs are the same, you're going to subtract. Subtracting these two will make it a 0. So, we will subtract everything. So, this becomes a 0 because 2 minus 2 is a 0. Positive 5y minus negative 1y by the rule of integers will become 6y equals 20 minus 8 is 12. Divide by 6. Divide by 6. Y is 2. Now you're going to use this to substitute for the y in any of this. I'm going to just use this one and copy this down. I am going to now substitute by making this become a parenthesis, and then I will plug in later. And then the y is 2, so I will plug that in. So my 2x plus 10 equals 20, and 2x equals 20 minus 10, and then 2x equals 10. That's going to be divided by 2, divide by 2. My x is a 5. So those are the coordinates of my intersection point for these two lines, and my solution is 5, 2. Okay, so for my example number 3, I have these two lines, 8x minus 2y equals 6, y equals 4x plus 3. The thing about elimination is you have to make sure that your terms that are like are all aligned. And so I'm going to tweak this a little bit. I'm going to copy this down on the side. 8x minus 2y equals 6. I'm going to make some movements on this one. I'm going to move this to the other side. So that becomes negative 4x. I want my y to stay on this side. So plus y. And I want to keep my 3 on this side so that they are now aligned. So I'm looking at this and I'm kind of thinking, okay, I need to eliminate something, and I'm looking at my 8 and my 4, and I can eliminate this if I multiply this by 2. But if I multiply this by 2, I'll have to multiply everything here by 2. So let's do that. So I will multiply everything by 2, including this one. So I will now have here negative 8x. I will distribute, that's what I mean, okay? Plus 2y equals 6. Now I will rewrite this and rewrite this because now they can be eliminated. I'm going to write it down here. So I have 8x minus 2y equals 6. And here negative 8x plus 2y equals 6. And I wanted to eliminate my x, and I'm seeing different signs. When you want to eliminate different signs, you must add, because adding different signs makes it a 0. So this is now a 0 plus, oops, look at this one. This will also turn to 0, okay? Equals, this time, this is 12. So what does this mean? 0 equals 12. Guys, this means that you have two lines that are parallel. When this happens, take note, your answer should be no solution because lines are parallel. And what that means is they have the same slope, but different y-intercepts. And once again, we said parallel lines do not intersect, and so therefore they don't have solution. All right, for our last and final example on solving systems of linear equation by elimination, I'm using these two lines. So 2x plus y equals 5, 4x plus 2y equals 10. Okay, they are all aligned, so I don't need to do any movements. However, I'm looking at my x terms and my y terms, and it seems like I could not eliminate unless I do something. And that something I'm thinking is multiplying this line by 2, this equation by 2. So I multiply this by 2. That means distribute. And so now it will become 4x plus 2y equals 10. And this is 4x plus 2y equals 10. Now, I want you to take a look. Before I even do my process, I want you to take a look something for me. Are you realizing that these two are the same lines? So watch and see watch and see what happens when I do the process of elimination, which this is, I will use subtraction. If I use subtraction, this becomes 0 plus 0 equals 0, and that is 0 equals 0. When this happens, I want you to know that your lines are going to be coincidental. That means that your lines, if you graph them, I will just approximate this. I don't even know if this is the right graph. But coincidental lines mean that this is a line, this is line 1, and line 2 is also on top of it. So that is the meaning of coincidental. Coincidental lines are on top of each other. Therefore, they have infinitely many solutions. Because they intersect at infinitely many points. And using the equation, that happens when this happens.